Hello, welcome to Sunday's edition of Cracking the Cryptic. And on screen we've got a very interesting and original looking puzzle from the American Maths Teacher RockyRoer. RockyRoer has featured on the channel a few times recently, always with some fantastically cool puzzles. So this one should be no exception. I'll tell you the rules in just a second. A quick reminder, I suspect most of you realise this already, unless you're anything like me and have no idea what the date is. But it is nearly the start of September, and at the start of each month we release our bonus content on Patreon, so our bonus puzzle. And we've got a timely puzzle, I think, this month, a Tour de France themed Sudoku. So if you are a patron of the channel, look out for that on the 1st of September. And right, let's get on to the rules of this one. I'll read them to you, and then I'll show you another puzzle actually, which will maybe make things clearer. What we've got is normal Sudoku rules apply. Each of the main diagonals contains the digits 1 to 9, so far not very unusual. Now, each of the clues outside the grid are little killer clues, i.e. they are the sum of the digits along a diagonal where digits may repeat along the indicated diagonal. But RockyRoer has forgotten in which direction he put the arrows in this puzzle, so it is for us to determine the direction in which the little killer arrows point. Right, now this is very, very cool. So if we look at this is another puzzle we did recently, it doesn't quite fit on the screen, but it'll make the point. You can see that normally when you have a little killer clue outside the grid, there is an arrow that points along a diagonal. Now in our puzzle, we get no such luxury. So this 35 could be an arrow that points up this diagonal or down this diagonal. So it would have to point at one of these edges. This 7 would have to point either this way or point that way, wouldn't it? So it would go this way. Let's do one more. The 12. So the 12 isn't ever using this square because it's the diagonal. So it's either going that way or that way. So that's how it works. I don't know what this means, but we will have to have a look. Now, as usual, the way to play the puzzle is to click the link under the video. With that, I get to play. Let's get cracking. And I mean, the first thing that strikes me when I look at this puzzle is that I don't think RockyRoer has been overly generous with the givens here. There are no givens in the grid and not many little killer clues, and those little killer clues we do have are ambiguous. The 35, that's the biggest number in the grid, and you can see that whichever direction this arrow points, it points at a 4-cell sequence. Now, 9, 9, right, and whichever way it points, the digits along that diagonal will have to be 9, 9, 9 and 8, because that's the only way we're going to be able to do that. And obviously in either of these two boxes we can't repeat the 9, so there's going to be an 8-9 pair in one of these two boxes with a 9 with 9s outside. So okay, right, so this is interesting. This is interesting because that means if we just label those 9s up, whichever direction this 35 goes in, the 9 in column 1 will have to be in one of those two positions, and the 9 in column 4 will have to be in one of those two positions. So there are no 9s in any of these cells. Now, does that reveal anything to us? Problem is, most of the other clues actually are small, aren't they? They're not. Oh, there's a 9 there, which. So if this 9 goes sort of down and right, it would place a 9 in this square because there is only one square on this diagonal. But if it goes this way, it would be. Oh, in this way, it would have to be very small. In fact, this way that's quite interesting. This 9 is either a maximum. If it takes this square, it's a single 9. If it goes this square, it has to have the very minimum digits. You'd have to have 3 1s along there, and then these 4 squares would have to be 1 and 2. So that would, I think that adds up to 9. Yeah, 3, 3 and 3. Yes. So, okay, well, that's all well and good, but it doesn't really help to explain what these 9s are doing. 7, that could be 1, 2 and 4 if it's 3 cells this way, because we would have to keep the digits different, and there's only one way of making 7 with 3 different digits. Or if it goes this way, oh, then it would also have to be a minimum. It would have to be 1 and 2 in these 2 squares with a 1 here. Ah, but the problem with this, whichever way this goes, we can't quite do an elimination because we don't know where the 1 would be in this sequence. Okay. So I don't think the 7 is where we start. 14? No, that looks a lot. That looks less constrained than the 9 does. 15 here? No, that doesn't look good. 14 here. We're running out of numbers to look at. No, 14's a little bit interesting in the sense that if it goes upwards, it has to take 3 cells from 2 different boxes. So, I mean, the minimum we can make 3 cells in this on this diagonal would be 6 if we made them 1, 2 and 3. So we'd have a minimum of 12 along this diagonal. Okay, 5. Oh, 5 is very limited. 5 is very limited in exactly the same way as, in fact, 5's quite interesting because if whichever way 5 goes, you can see the only way of making 4 cells add up to 5 is you've got to include 3 1s and a 2. So we would have to have 1s in those squares. So it's a bit like the 35 with the 9s. We now know that in row 9, the 1 cannot appear in those squares, and in row 6, the 1 cannot appear in these squares, because whichever way this 5 goes, there will always be a 1 in one of those 2 positions. Now, the other thing I noticed there was that this 5 and this 35 share this diagonal. So they can't both use it. Or, of course, it's possible neither of them use it. It's possible that the 35 goes up there and the 5 goes that way. But if the 5 goes this way, then the 35 would be forced to go... Sorry. If the 5 goes this way, the 35 would be forced to go this way. Now that's quite interesting, actually, because that would force the 9 here, then couldn't have a 9 in this cell, because there would be a 9 here. So the 9 would have to be a long 9. No, right, okay, we found a break-in. Let me explain. So it's the interaction, I think, of the 5, the 35, and the 9 clue. If the 5 goes left, this square would have to be a 1. This square would have to be a 1. These 2 squares would be a 1-2 pair. The 35 would mean you get a 9 here. Come on, 9, 9. This would be a 7, 8, sorry, an 8, 9 pair. Now, the clue we've now got to think about how we could fulfill is this 9 up here. You can now see we obviously can't have the diagonal coming here because that will repeat the 9 in row 1. So the question is whether the 9 can go down here. Now, this was very restricted. And you can see immediately it's just impossible because we're going to have to put a 1 in this square. We'd also have to put a 1 in this square, and that's also going to clash. And we'd also have to have a 1 in this square. We'd also have to have a 1, 2 here. So it breaks for many different reasons, but this 9 is utterly broken if we start from the premise that the 5 clue goes left. So the 5 clue does not go left. We can say that with certainty. So let's get rid of some pencil marks. The 5 clue does not go left, the 5 clue goes right. So this is a 1, this is a 1, and this is a 1-2 pair. And we can... So how do we use this now? I don't think these ones interfere with a sort of putative 9 clue down there, because this could still be a 1. Ah, it interferes with the 7 clue. Yes, look, if this 7 clue goes down and right, it takes those squares. And we knew that these would all have had to be 1 and 2 with a 1 here to make these 5 squares add up to 7. Well, you can see these are absolutely impossible. The minimum value I could put into these squares now, once there's a 1 here, is a 2 and a 3. 2 plus 3 plus 1 would mean I'd have to put cells summing to 1 into 2 cells there, which is impossible. So we actually know this 7 clue comes down here. Okay. I don't know whether I should label these diagonals once I've sort of got the clues. Okay, what do I do now? Ah, this 12, can this 12 clue go right? 1, 2, if the 12 clue goes right, we've got a problem. This has obviously been picked at 12 for a reason, because what is now the minimum value we can make these squares add up to? Well, because we've got 1s in these 2 boxes, the best I could do would be a 2-3 pair there and a 2-3 pair there. So those 4 squares already add up to 10, so I need to keep this one to 2, and I can't because there's a 1-2 pair in. The best I can do for that square would be 3, and those 5 squares therefore now have a minimum value of 13. So this 12 clue must go this way. I am going to start colouring these in actually, because I think otherwise I'm going to forget which clues I've used. So let's colour those in. The 13, for exactly the same reason as the 12, the 13 can't go up and right, because those 6 squares, the minimum I can make those now is 9, because are 2, 3 and 4, 2, 3 and 4. 2 lots of 9 are 18, so the 13 goes this way as well. So now the purple and the blue in box 7 add up to 25, so the open squares add up to 20, because we know any box of a Sudoku contains the digits 1 to 9, and 1 to 9 add up to 45. I know you enjoy how often I say that. But 20 and 4 cells, we don't really know what that means. It does mean this 35 could still come down this way, because that would put 8, 9 in here and 1, 2 in here. In fact, that would be really nice with the 1 there. Can we work out which way this 35 goes now? Oh, this 12 going this way means this 11 can't go this way as well. 11 does not equal 12. So the 11 must go this way. So these squares add up to 11. So if these squares add up to 11, how many degrees of freedom have we got here? If we go 1, 2, this square could only be a 3 as a minimum because of the 1, 2, 4. So we go 1, 2, 3, 4, 5. So we get 9 as the minimum at the moment. 3 plus 1 plus 2 plus 1 plus 2. Just wondering whether we can, the fact that this has to add up to a relatively low number, does that impact on whether this 9 clue can come down to the left here? this 9 clue comes down here. The 9, it does. This is very important because if the 9 clue comes down and left, we know it must place 1s and 2s into those two cells. That's the only way we can keep the 9 clue low enough, which means these squares here would have a minimum value of 7. We'd put 3 and 4 into them. But 7 and 7 is 14. It's much bigger than 11. So we actually now know that this 9 clue goes here. Which means this... so the 35 clue does not go upwards. The 35 clue goes downwards. And we get some more digits. This must be an 8, 9... now this is important because now with these being 35 and in particular these being 17... I know these, from the box logic we did down here, these two squares have got to add up to 3, and they have to be 1 and 2, and you can see we have a 1 here already. So 1, 2, 1, 2. This square's not 2, this square's not 1. This clue is done. I'll shade it in to try and remind me I've used the 9 clue. I've used this clue down here. That's the 35. So I've allocated... I haven't looked at this 14 actually. Oh, well the 14 is broken by the 9. Isn't this 9 on... Yes, it is. This 9 is on this 14 diagonal. So if the 14 came down and left, we would be broken because the minimum I could make those 3 squares, for instance, would be 6 if I made them 1, 2 and 3. So the 14 takes those 2 squares and it can't use a 9 and it must be 6 and 8. What a clever puzzle is that? It's fantastic the way this is building up. Okay, so what do we do now? Oh, now we can use this 1. Where do we put 1 in box 3? We've got 1s here and here, so it has to be in one of those 2 squares. There's 1 on the diagonal, so it can't be. We can't repeat digits on the diagonal. The 1 goes here. 4, 2, 1. So 1 must be limited in the central box. Nearly. Not quite though. It's going to be in one of 2 places. 1 must be in one of these 2 cells. 1 must be in one of these 2 cells. And I've used the 14 clue. I must keep remembering to label this up. So I don't think I've got either of these 2 clues yet, the 15 or the 14. So if the 14 goes upwards, it's a shame this 1 is on the diagonal. There's some sort of interaction with this 11 diagonal, but I can't quite get my head around how it works. Right, hang on. Let's have a stare. So the best value for this would be... Let's imagine that this square is not 3. If this is not 3, it has to be 5. And now the 11 diagonal is really restricted. I have to put 1 and 2 into those 2 squares. I'd have to put 1 and 2 into those 2 squares. And that's interesting. That breaks the central box of the grid. Because if you can see from where I've pencil marked 1s in box 2 and pencil marked 1s in box 4, that if I have to put 1s on this diagonal in those boxes, they would have to go into those 2 squares. But now I can't put a 1 anywhere in box 5. That's rather clever. So I think what RockyRoer wants us to realise is that this square can't be a 5, so it has to be a 3. And in fact, I can never put more than 1 1 on this diagonal for this very reason, because of these 2 1 pencil marked I've got already here. So if I can only put 1, 1, the other 3 squares have to add up to 7 without using a 1. So they've got to be 2 2s and a 3. This is beautiful. This is just beautiful the way this is working. Because now what we've worked out is that this diagonal has to include exactly 1 1, exactly 2 2s, and exactly 2 3s, and we have one of those 3s already. Now that means there must be 1 2 in this twosome here and 1 2 in this twosome. Now where do I put those 2s? Well, I can't put them in those 2 squares. So these 2 squares are 2s, and these 2 squares are a 1 3 pair. And now, can we use that to our advantage somehow? Yes, we can. Where does 2 go in box 3? It can't go on this diagonal because of this 2 hidden in the bottom left-hand corner, so it's got to go there. That means 2's in one of these squares. 2's in one of those 2 squares. And I suppose I've got to figure out... 2 has got to appear on this diagonal. It's not appeared yet. And it can't appear in this square, so it appears there, and that's going to finish off all the rest of the 2's. Beautiful. Oh, not there. Let's get rid of those. So we've done all the 2's. And right, now let's revisit this 14 diagonal again. Because now if this is a 2, the first 3 squares here have become problematic. The minimum I could make them now would add up to 8. And that's perfect. I can't make them add up to 8, because if I do, let's say I made those 3 and 4. Now to get to 14, if this clue does come vertically and to the left, those 3 squares would now have to add up to 6, and they can't because the 2 has already disappeared as a possibility. In fact, look, in this row, there's all sorts of... That square has a minimum value of 5, so it just utterly breaks. So the 14 comes down here. And neither of these squares can be a 9 because of these 9s. So this must be 6 8. Which sees 6 8s up there. Oh, this is gorgeous. So now we've got to think about where we put 6s and 8s in column 7. We can't put them in those 3. We can't put them in these 3. So they must be in those 2. Where does 9 go in column 7? 9 here means it's not in these 3 squares. We've just proved it's not in those 3 squares. This one means it's not in that square, so it's in this square. 9 is off the diagonal up here. This 9 fixes this 8 9, look, so that's got to be 9. That's got to be 8, which means that's 9. 9's in one of those 2 cells. 9's in one of these 2 cells. And 9 on the diagonal, where it can't go there or there or there or there. It's in one of those 2 cells. So okay, so you can see this pattern here. I don't think we can resolve. Maybe it helps with a diagonal. Which diagonals haven't we done? Let me just have a look. We've done this one. Done this one. That had to go this way. The 13 had to go... Oh, the 13 had to go this way. And it can't be 5, 8 or 4, 9. This has got to be 6 and 7. Oh. So there's a 6 in one of these 3 squares. Just looking at where 6 can go in row 9 of the grid. These 3 squares have got to be 3, 4 and 5. 3 can't live here. Okay. But anyway, I've definitely done these 3 diagonals. I've done some work on this 11. I know which way it goes. The 35 goes this way. The 7 goes this way. 14, 9. So it's just the 15. It's 50. It's the 15 and Sudoku. Okay, that's all we've got left to do. So if the 15 goes downwards, these 3 squares would have to add up to 15. Is that possible? What have we got left? We've got 3, 4, 5, and so 3, 5, and 7. They add up to 15. So these would have to be 3, 5, and 7. Is there a reason that's impossible? Don't know. I don't see anything immediately wrong with that. If the 15 goes this way, it has to go into the, this might be interesting. Because the minimum value of those 2 is 3 and 4. The minimum value of this one now is 5, I think. So 3, 4, and 5 is already adding up to 12, which means these 2 squares would have to add up to 3, which is impossible because the 2 is not available. In fact, there's another way of looking at that, which is rather cute as well, looking at the 9s. Whichever one of these is a 9, it pushes a 9 onto this 15 diagonal, doesn't it? If this is a 9, this has to be a 9, and that's on this diagonal. If this is a 9, that has, yes, so one of these 2 yellow squares has to be a 9, which is another way of ruling out this 15 diagonal going upwards and left. So however we do it, we definitely end up with 3, 5, and 7 there. This square must be a 4. This square can't be a 3 because of the 3 on the diagonal. The 4 here, look, sees that square. That must therefore be a 5. That can't be a 5. This 4 means this sorts out the 3, 4 pair. This 3 sees that square, so that's a 1, which means we need a 3 to make sure this adds up to 11. And now we've just got loads and loads of new pencil marks to deal with, so I better go a bit more slowly, I think. There's got to be a 3 here. There's got to be a 3 in one of those 2 cells. This square here has got to be a 6, 7, or 8, just looking at row 9 of the grid. Oh, we know it can't be a 6 because, yeah, we'd already locked the 6s out, so it's a 7 or an 8. This 3, and where does a 3 go in box 3 of the grid? It must go on the diagonal because it can't go in these 3 cells. Which means 3 shunts over to the column 9 in box 6. Now, can we say anything? So 3's got to be in one of those 2 squares. 3 in the central box, look, is quite limited by the 2 diagonals, both of which have 3's on them. So we can't put 3's in those 2 squares. This 3 means we can't put 3's in those 2 squares. So the 3 has to be in one of those 2 positions, which means that's not a 3, that's not a 3. So we get 2 3's for our trouble. Now, okay, so what do we do next? Here's something. We've not put 8's or 6's on this diagonal yet. So they've got to go in one of, or 2 of those 3 positions. Unfortunately, we don't know much about 6's and 8's. These 3 squares have got to be 4, 5, and 7. Maybe we can get something from that. I can see that we can't have a 4 here because of this diagonal. So this is a 5 or a 7. Sorry about this. Brief hiatus, hopefully a brief hiatus, while I try and work out what the next devious piece of logic is that RockyRoer has built into his puzzle. 5, 6, 7 and 8 down here. Let's highlight all of that and see if we can see anything good. Maybe 4s. Are 4s limited somehow? 6 and 8. There's a 6-8 pair in column 9. So this square has to be a 5 or a 7. There's also a 6-8 pair in column 8 as well. Is it possible to resolve these 9s? In fact, I've got all these questions. Have I used up all my diagonal clues now? This 14 is used, this 9 is used, this 7 is used, 35 is used, 11 is now completely used, the 6, 7 is used, the 12 is used, the 5 is used, the 14 is used, and the 15 is, yes, the 15 is used. So we have, so the little killer part of this is completely now resolved. We've just got a Sudoku X left. We've just got to figure out how to solve it. Okay, which is not looking easy. I feel like I should look at the diagonals more though. This diagonal, let's look at this diagonal. We still need to place 5, 6, 7 and 8 on this diagonal. That can't be 8. Just don't know much about 5s, 6s, 7s and 8s in the puzzle in general. This 8 here, there's no 8 in these squares. There's got to be a 6 and an 8 in these 3 squares here because of the 6, 8's position in rows 1 and rows 2 in boxes 1 and 3. Five, 6, 7, 8. 1. This 1. Just use my pencil marks, look. So that means this square can't be a 1. So this is a 1. Which this is important, because that means this is a 1. It also means, where do I put a 9 in this box? It's got to go here, which resolves both sets of 9s in these peripheral boxes. Just checking what I had penciled under that. I had a 3 under that. So now the 3's get placed as well. That's all good. 7, 8. Okay, can we keep this going? So these squares here are 4, 5 and 7 in some order. There must be a 4 in these positions. Four, look, this 4 means there's a 4 in this domino. So there's no 4 in any of these cells, so there's a 4 in one of those 2 positions. Wow, this is not easy to finish. 5, 6, 7, 8. I tell you one thing we can do though. If we know this diagonal needs a 6 and an 8, and the 6 and the 8 can't be here, so the 6 and the 8 on this diagonal are definitely in 2 of these 3 squares, which is why we've pencil marked it. Then what can this cell be? This is very clever. Oh goodness. Well, it can't be a 6 or an 8. And looking at the diagonal, it can't be 1, 2, 3, 4 or 9. So it must be 5 or 7, which means it joins up with this square, and means this square can't be a 5 or a 7. This square also can't be a 5 or a 7. Now, because of the 5, 7 pair on the other diagonal, So this square is just left with being a 6 or an 8. This is crazy. Now, that was a lot of work to deduce that this square here is not a 5 or a 7. Why on earth does that matter? I tell you why it matters. It matters very much indeed. What can this square be? This is beautiful. The way this square has an effect around the perimeter of the grid in the blue squares. If this square is a 6, this square has to be a 6, this square has to be an 8, and this 6 and 8 point at that square. And it can't be anything. And that's no good. That's lovely. So the 5, 7 on this diagonal lead us to this 6, 8, which leads us to the fact this has to be an 8. So this is a 6, this is an 8, which, we get these as well, 8 and 6. We get the 6 and the 7 now. Now, do we get more? Yeah, we get a 7 here, look. This 7 gives us a 7 and a 5. This square must be an 8. Wow. And suddenly the puzzle looks like we might be able to solve it after all. So this 5 pushes a 5 into this square, which means that square must be a 5 using our pencil marks. This is left with being a 4, 7 pair. This can't be a 6 anymore. If we look at this column, we've not placed 5 and 7. This now has to be 7 because it can't be 5. So 7 goes here, 5 goes here, 7 goes here, 4 goes here. We can remove 5 and 8 from those two squares. And this one has to be 6. My phone's buzzing at me, but I'm going to ignore my phone because RockyRoer's puzzle is more interesting. So this has to be 4 or 7 to complete this row. This row needs 4 and 5 to complete it. Oh, I need to be able to see my keyboard. This 8 forces the central square to be a 6. This 5 means this square must be a 7. I sort of feel like this, what we've found out about this diagonal is just so important. 4, 6 and 8 into those squares. This is obviously 8. The 4 and the 6 don't look like they're quite resolved yet. This square can't be a 4 because of the earlier pencil marks we found. This square must be a 5 or a 6. This, look at this column. We need 4, 5 and 6 to complete the column. This square can't be 4 or 6. This has to be 5. Which means that's 6. That's 4, 5, 6 now. This 5 fixes the other diagonal, gives us a 7 here, 4 here, 7 here, 5, 4 here. This must be 8 to complete that diagonal. 8, 6, 6, 4. 4 should go there, I think. And let's just take our time and make sure we're getting this right. We need 5 and 8, so 8, 5. That looks good. Check. Does that say looks good to me? It does. That's how to solve another gorgeous, minimal Sudoku from RockyRoer. I was a bit slow in the middle when I didn't spot this 1 had an effect on the central box, but apart from that, I wasn't that unhappy with the solve, actually. There were quite a few difficult steps, or at least difficult for me. I always look out for your comments. I always see some of you are nailing some amazing times. It makes me feel very, very humble. But anyway, thank you for watching, and come back later for another edition of Cracking the Cryptic.